So, section 9, question number 8. Okay, so standard higher questions. Calculate the current. Here we go. Through a mini fan if the voltage is 400 millivolts and the power is 5 kilowatts. So current, we don't know. Voltage V, potential difference 400 millivolts, which is equal to 400 times 10 to the minus 3. Power is equal to 5 kilowatts, which is equal to 5 times 10 to the 3. So power is equal to IV. Substitute my numbers in. So I've got 5 times 10 to the 3 is equal to I times 400 times 10 to the minus 3. So divide both sides by 400 times 10 to the minus 3 to give I as the subject. And that will leave us with an answer of 12500 amps. 12500 amps. So it's hardly a mini fan. I would say it was a massive fan. If it's got 12,500 amps going through it. In fact, I would suggest that you stay well clear of that fan. Now, a motor has a power of 20 kilowatts and is supplied by mains electricity. What is the current flowing? So I don't know. I'm told that I've got power is equal to 20 kilowatts. And now, oh god, I'm panicking. Let me read the question again. A motor has a power of 20 kilowatts and is supplied by mains electricity. Mains electricity, V. That's equal to 230 volts. So I need current flowing, so I know power is equal to IV. Substitute my numbers in. So 20 kilowatts is 20 times 10 to the 3, and that's equal to I times 230. Divide both sides by 230, and that will leave 20 times 10 to 3 divided by 230, okay, which is equal to I, which is equal to 86.956 amps. It says here's two significant figures, so I'm just going to call that 87 amps. Moving on then, number 10. Oh, there we go. So, what is the resistance of a bulb? Well, resistance R. A bulb that has a power of 20 watts of voltage across it for 8 volts. So, power is equal to 20 watts, and I've got voltage is equal to 8 volts. So, I've got R, power, and more significant figures, and I've got voltage, so I need R. Okay, now from Ohm's law, R, resistance, is equal to voltage divided by current. So I don't have, I've got voltage, don't have current. So what's current equal to? Well, in this case I've got power, so it's got to have something with power in. So power is equal to IV. Okay, now, so power, 20 watts, is equal to I times 8. So make I the subjects, 20 divided by 8, that's going to be 2.5. So I now know that I've got 2.5 amps of current, and I can now substitute that back into here. So we've got R is equal to V over I. So V is 8 volts, current is 2.5, so that gives me 3.2 ohms. Could check this if we wanted. Since power is equal to I squared R, then what we can do is we can rearrange this to give me R is equal to power over I squared, which is equal to 20 divided by square root of 2.5. No, sorry, 2.5 squared. So 20 divided by 2.5 squared is equal to 3.2. So I'll check there. Right, number 11. The circuit is a bulb and a resistor in series. The switch is turned on for 3 minutes and 450 coulombs of charge flows. The voltmeter reading across the bulb is 5 volts. What is the power of the bulb? So power, I don't know. It's on for 3 minutes, so time is equal to 3 minutes, which equals 280 seconds. And I've got Q, 450 coulombs, and I've got a voltage of 5 volts. So there's a number of different ways I could do this. So right, and look at power. The power is equal to IV. I've got V. I need current. I've got Q and T. So I do know that Q is equal to IT. So substitute my numbers in. I've got 450 is equal to I times 180. So 450 divided by 180 will give me I, which will give me 2.5. Now I can then use power is equal to I times V. So power is equal to I times V. So that's equal to 2.5 times my voltage, which is 5, which is going to be 12.5 watts. Look up there, so it doesn't tell me about significant figures. So I've got 12.5 volts. So the power of the bulb is 12.5 watts, which is roughly about right. That's about the wattage flowing through a car battery bulb, not an LED, an old style. A bulb is plugged into mains voltage for 5 minutes. So question number 12. 920 kilojoules of energy is transferred. What current flows through the circuit? To two significant figures. So current, I don't know. I've got 5 minutes, so time is equal to 5 minutes, which is equal to 300 seconds. And I'm told that 920 joules of energy. So E is equal to 920, not joules, but kilojoules, which is equal to 920 times 10 to the 3. What current flows? So looking at this then, we've got power is equal to IV. I've not got voltage. Oh, I have. It's a mains voltage. Wow, that's 230 volts. So power is equal to IV, so I'm working out current. So I've got power. Let me think about this. So current flows. So we're going to need, well, power is equal to IV. So I've got V. I haven't got P. So could I find P? Well, P, okay, is equal to the energy transferred per unit time. So have I got energy? Oh, I have. I've got time. Yes. So it's going to be 920 times 10 to the 3 divided by 300, which will give me 3066.6 watts. Now I've now got power. So power is equal to IV. So I've got 3066.6 is equal to I times V, 230. So 3066.6 divided by 230 is equal to I, which is equal to 13.33. Two significant figures, so it's 13 amps. So, last one then. So, the series circuit has two bulbs. One 4 ohms, 3 ohms. Potential difference of the supply is 28 volts. How much total energy is transferred by both bulbs if they're both on for 4 minutes? So, we have supply of 28 volts, two bulbs, and we've got 4 ohms and 3 ohms. So they're in series, so that means the total resistance is going to be R1 plus R2, which is equal to 4 plus 3, which is equal to 7. So that's my total resistance, 7 ohms. And then my total voltage, VT, is equal to 28 volts. What else am I told? I've got time, and it's on for 4 minutes, which is equal to 240 seconds. So I need to find out the total energy transferred. So let's box that. So energy is equal to what? So I know that energy is equal to PT. I know that V is equal to energy per unit charge. So I've got my voltage, charge, Q equals IT. So if I find Q equals IT, if I find my current, then I can find charge, and then I could find energy this way. Oh, well, why not? So we have current, so Q is equal to IT, so Q is equal to I times 240. So I need to find I first. So if we look at this then, V equals IR. Well, we've got V, so let's just slot numbers in. I'm not particularly happy about doing it that way, but 28 is equal to I times resistance 7. So we have 28 divided by 7, and that will give me 4 amps. So now I can now slot this in, and I can say that Q is equal to 4 times 240, which is going to be equal to 960. So I've now got voltage, V is equal to energy per unit charge, substituting my numbers in. So that's voltage, which is 28, is equal to the energy divided by charge, which is 960. So E will equal 28 times 960, which is going to be equal to 26,880. It's energy, so it's joules. Okay. Now you could do this slightly differently and use energy, power and time. So if we were going to do it that way, let's just check. Energy is equal to power times time. We can actually work out power using IV, which is going to be equal to 4, my current here, times voltage 28, which gives me 112 watts. Now energy is equal to 112 watts times time, which is 240. So that, if you put that into a calculator, is equal to 26880 joules. So correct using both methods.